Sir, could you please explain what a super mesh is?
In certain problems, we have current sources in between two loops. In that case, what we do is we consider the current source as well as a resistance in series with that as a super mesh, and then we write a super mesh equation between I1 and I2. So, we shall write super mesh equation for this particular problem as this. There is a voltage rise, there is a drop here, there is a drop here, and there is another drop here. So, voltage rise is minus 20, voltage drop is 6 into I1, another voltage drop is 6 into 10 into I2, and then the fourth one is 4 into I2. This is one equation at the super node. And the other equation, what is the other equation? That means, what is the net current that is flowing? The net current is I2 minus I1, because I2 is flowing in the same direction as the current source. I2 minus I1 is given as 6 amperes. So, what we have to find out is I1 and I2, we have two equations. One equation is this, second equation is this. So, we can simultaneously solve these two equations to find out the current I1 and the I2. In this particular example, I1 is, we got it as minus 3.2 amperes and I2 as 2.8 amperes. So, we found out the solution. Finding out the solution means finding out all branch currents, branch voltages. So, we can get the voltage here as I1 into 6 ohms. So, we can get the voltage here as I2 into 4 ohms. So, like that we found out the voltages and currents. So, we get the solution in this way. To illustrate super mesh, we shall take a more complex problem. In this particular example, we have three sources, one current source here, second dependent current source here, an independent voltage source here. And then if you identify the number of loops, we have how many? It is a one loop like this, second loop, a third loop, and a fourth loop. There are 4 loops. So, we have to find out the I1, I2, I3 and I4, and how many equations are possible. Because there is a current source between 1 and 2, we have a super mesh here. And then there is a dependent current source here between the loops 2 and 3, therefore, we have a super mesh here. So, these two super meshes can be combined in this particular loop, and we write an equation for this. We write another equation for the loop 4, and we write a third equation in this super mesh, and we write a fourth equation for this super mesh. So, we have 4 equations and we have 4 unknowns. That is how we can get the solution. Let us see how the equation for the first mesh 1 and 2 is written. Let us say first super mesh is this. So, you have the second super mesh is this, these two. We combined the first super mesh and the second super mesh and written an equation in this. Let us see what it is. Let us start with this. We shall start here and come back here again. So, the drop across this is I1 into 2, the drop across this is I3 into 4, and the drop across this is 8 into I3 minus I4, and the drop across this is 6 into I2. This is KVL for the super mesh. Then for independent current source, that means this, what is the net current that is flowing here? That means I2 minus I1 is 5 amperes, because this is a source, 5 amps always will flow in this. And what about the dependent current source? This is the dependent current source. Current source I2 minus I3 is in the opposite direction. So, minus I3 equal to 3 I0. This is the value of dependent current source. Then how is I0 defined? I0 is the current flow here in this particular source. It is going up, but we have taken the convention as going down. That's why I0 is minus I4. So you just look into the number of equations 1, 2, 3, 4, and how many unknowns are there? 1, 2, 3, 4. So simultaneously we solve that 4 equations and finally we get the solution like I1 equal to minus 7.5 amperes, I2 equal to minus 2.5 amperes, I3 as 3.93 amperes and I4 as 2.143 amperes. So we got the solution. So in the mesh analysis, getting the solution is finding out the loop current.